Okay, so let's say this is an exploit or a vulnerability that we can use to hack into a system. So security vulnerabilities and exploits are mostly found in some unpatched services or some programs that are badly coded. So the intuition here is that there is no system that is 100% secure, and in any running system and servers, there is definitely exploit and loophole that we can find to hack into the system. Now the problem is that most of the bug or the exploit are unknown to the users and sometimes even developers themselves. It is only possible to find out these threats when we hire red teamers to do some penetration testing on the system to find out some of the vulnerabilities that are still open on the server. The enumeration process simply means finding this potential bug or this exploit in some of the services that is currently vulnerable, so that we can leverage on this program to hack into the system. So how do we know among these programs which of it is currently vulnerable? Now of course there are a few ways you can do this. The first way is we can use this popular script called piece, which will systematically scan on most of the common vulnerable places so that we can quickly find out which of the services currently contain the bug that we can use to our advantage. Or you can just use your spider instinct. One of the common places to find such a loophole is in the Unix binary with the SUID set to 1. So GTFObins is a collection of such binaries that attacker can use for privilege escalations. From the GTFObins website, you can see that these binaries can be abused to do many things, which is not limited to breaking out from lower level shell, escalating or even maintaining privilege, and also to spawn a reverse shell. For the full list of binaries that you can exploit, browse the GTFObins website to get the full collections of the binaries. So here's an example to help you understand more about GTFObins. Now, firstly, let's take a look at the users that we have on the system. We have a root user, of course, which is having user ID 0, a user called if with the user ID 1001, and a user called www.data with the ID 33, which is quite common in most of the web server. Just to add that, you can easily find out what's the user ID for all these users by checking the password file, which is located in the etc directory with the name passwd. So as you can see here, this is how I find out if is currently having the UID of 1001, and we can also look for www.data which is having 33, and also the root which is always having the value 0. The second value here indicates the ID for the group. In this example, since we have not assigned if to any of the group ID will be the same as the user ID. Now, we will take a look at SUID bit on a Linux system and understand how does it work. So if you have been installing programs on the computer, some of the time you might notice that you are asked whether you want to install this program only for yourself or for any other users that might also be using the computer. So if you choose the options to install the program for all the users, this means that on a machine that have multiple user accounts, any user that manage to log in to the system would be able to run the program that has been installed by you. Now in this example, this program belongs to you, so you are the owner of this program and the other user would be considered as the guest user when they are running the program that you have installed. Similarly, in a Linux system, when a file or directory has the S bit set to 1, this allows other user to execute the file as the owner of the file. In our example, says if install a new program called Mobile Legend with the S bit set to 1. Another user on the same system called www-data try to execute the program. In this case, www-data will have the permissions to run this file because the S bit has been set to 1, and while running this file, www-data will be running this file as if which is the owner of the file. So S bit is somewhat different from the X bit that we normally see. In the same example where if install the program Mobile Legend, but this time the executable bit is set to 1. In this case, www-data will have the permissions to execute this program, but instead of running this program as the owner, it will be running the program as himself using his own UID. So to summarize, the difference here is that for the S bit, the other user will be running the program as the owner temporarily, while for the X bit, the other user will be running the program as himself instead of acting as the owner. The real user ID or RUID refers to the ID of the user that is currently logged in into the system. Most of the time, this RUID value will not change regardless of what program that we are running. For example, says that if www-data is currently logged in into the system, regardless of what program that he runs, all the RUID will always be 33, which is his own UID. Meanwhile, the effective user ID or EUID will always change depending on the file that we are running. So this EUID will change to the ID of the file owner of the file that we are running. For example, let's say www-data now run Mobile Legend S, which belongs to Eve. The EUID will change to Eve EUID, which is 1001. So that is how RUID and EUID are different. Next, we will take a look at how the RUID, EUID, and SUID changes while if and www-data is running Mobile Legend S. As you can see here, the S bit has been set to 1. In our first case, say if himself, which is the owner of this file, tries to execute the program. In this case, since if started the shell and run the program, the real user ID is if user ID, which is 1001. Remember that RUID would never change regardless of what program you are running, and it always depends on the user which is currently logged in into the system. For the EUID, because this is the version with S bit set to 1, any user that is running this program will temporarily become the owner of the file, which is if for this case. Since if himself is the owner, the EUID will still be the same 1001. And it is also the same for the SUID bit, which is also 1001. in case number 2, we are still running Mobile Legends S. This time, www data is trying to run Mobile Legends S. In this case, remember that the real owner of this file is not www data, but instead it is if. However, www data will be able to run the file because the S bit has been set to 1. In this case, the real user ID, RUID, would be 33 because it depends on who is currently logged in into the system, and right now it is www data with the ID 33. As for the EUID, this should be the UID of the file owner, which in this case is if, and that should be 1001. And again, it is the same for SUID 1001. So as you can see here, when www data is trying to execute Mobile Legends S, it is temporarily elevated as if user because the file that he is currently trying to run belongs to if. Now, in some rare cases, when the other user like www data temporarily elevated to if, as you can see in this case, they could try to stay longer than they should. And this is similar to the concept of GTFObins, where when we execute a file with S bit set to 1, instead of getting back to our own privilege, you try to stay on using the privilege that we have just gained when running any program that has S bit set to 1. So to summarize, GTFObins is an exploit where a user tries to run a file with S bit set to 1 to gain higher level privilege access. So www data managed to gain access into if account by running the Mobile Legends S and pretend that he is the if user. So next, I'll run the Mobile Legends S as www data, but as you know, we cannot directly log in to this account due to some Linux restrictions. So instead, I'll be running the Mobile Legends as www data from the root user. So this is the command that I'll use. I'm trying to run as www data, and the program that I'm running is currently in home/if directory. The name of the program is Mobile Legends S, and these are all the parameters that I need to run the program. So if I press enter and I do who am I, you can see that now currently the system sees that I am if user, although I'm supposed to be www data. Now let's try to take a look at the RUID, EUID, and SUID when we are running Mobile Legends as www data. So again, first thing, I will do ps-e to find out the program ID, and in this case it is 6706. Next, I will do ps-e-o to output the PID, which is the program ID, the RUID, the EUID, and the SUID. So from here we can see that 6706, which is Mobile Legends S. The RUID right now is 33, which belongs to www data. Meanwhile, the EUID is 1001, which is if, which is also the owner of this file, and the SUID is also 1001, which is again if, the owner of this file. So to summarize, the RUID will not change. It will always be the ID of the user that is currently logged in into the system and running the program, while the EUID and the SUID will be changed to the ID of the file owner. Now, for today's challenge, we will be using GTFObins to gain access to some higher level privileges. So firstly, we will try to gain access to the WordPress server, which is running on 119.7 from our curly box, which is having IP 119.5. Once we start a reverse shell into the server, then we will be logged in as www data. The next thing we want to do is to use the GTFObins exploit and try to escalate us from the www data to if user. First, we will start a reverse shell from the curly box to the WordPress server. This can be done using the PHP reverse shell that you can find under the laudanum script in your curly box. And to learn more about how to start a reverse shell, you can watch this video here. From here onwards, once we bind the reverse shell, we can now use our curly box to gain access to the WordPress server. Initially, when we first got in, we will be logged in as the www data, which is quite common for any web server. Now, we are going to find some possible GTFObins exploit that is currently found on the server so that we can escalate from www data into if user. The next thing we do is try to scan the system to find all the binaries and files that is currently having the S permissions. So we do a scan to find all the files with S bit set to 1. Over here, we realize that there are a few binaries that is currently having the S permission, which we will later use to our advantage. After scanning, we get a list of binaries and files with the S permission, and those are the files that we can use to our advantage to run the GTFObins exploit. For example, says if this file nice belongs to if, and it has the S bit set to 1. Currently as www data, I can run the nice binary using the syntax that I get from GTFObins website, and if it is successful, then I will temporarily gain access to if, and now I can choose to stay on as if until I decided to quit. Another example would be if I try to run this float binary which belongs to the root user. As www data running float using the syntax that you can get from GTFObins website, if the exploit is successful, you will gain access to the root and act as a root user until you decided to quit. So now let's look at a demo on how this works. Now in this example, I started a Netcat listener listening on port 12345 to gain access to the WordPress server. I already had a PHP reverse shell embedded in one of the web code, and whenever I try to go to the page that doesn't exist and the 404 error message are triggered, I will gain the reverse shell. So we can do a who am I here, and you can see that we are currently logged in into the WordPress server as www data. Remember, our challenge is to go from this user to a higher privileged user, which is if. So in fact, if you want to see all the users that's currently available on the system, you can just cat the password file, and this if user is the next user that we are trying to gain privilege to. Now if I try to do an ls here, I can see there is a home directory, which is the directory that keeps all other users' directories. So we'll cd into home and ls to see that currently there is another 2 users on the server, one named Avo and another named if. So our target now is if, and we can actually cd into if directory to see all the files that's currently on the if folder. So coming back to the concept of GTFObins, if we manage to find there are certain files that has a S permission, we can use the GTFObins exploit to try to run that file as the file owner and then stays on as the owner. Now of course, you can always use the limpy script to automatically find out all the files on the system that's currently having S permissions that you can use, or you can just use the find commands to find out all the files that's currently having SBIT set to 1. So I'll use the find command, and I'm finding for the whole system, and I'm looking for the permission with the user bit set to S, and I'll finish with this, which is something that we commonly type to ignore all the system messages. Press enter, and now the search is running. So in a while, you can see that all these are the script or services that is having SBIT set to 1, which means that they could be potentially vulnerable to the GTFObin exploit. Now, taking at a look here, we can see there are a few interesting files under if and our folder that has the SBIT set to 1. Now, this is our way in. Since we are targeting if, we will be interested to see if all these services that has the S permission is vulnerable to the GTFObin, and we'll try them one by one. So to see all the file permission, use the ls-l, and you should see that right now I have 5 files here that has the SBIT set to 1. So in fact, we can just randomly pick any of them. So as you can see here, I have cleaned the screen a little bit for clarity. So we started by checking out who we are, and then we get into if folder, which is under the home directory, and we list out all the files that is currently on that directory, and we found that there are a few files that has the SBIT set to 1. And let's carefully check at the file ownership. We have a file named flop, which is owned by the root, and we have another few nameless nice special file which is owned by if. Now, since we are targeting if, we should use any of these files that belongs to if to gain access to if account. Let's say if we use this flop here, if the exploit is successful, then we will instead gain access to the root user, which is actually even more rewarding. So I'll show you two examples, one by gaining access to if, and another by gaining access to the root. Now, to find out how to execute the exploit, simply go to GTFObins, where you'll see a list of collections of all binaries that is vulnerable to this exploit, and just look for the file that we are going to run the exploit on. So let's say I want to use nice as an example. I'll look for nice, and you can tell that this is vulnerable to the GTFObin exploit because you had the SBIT set to 1. Go inside and you can see this line of command. This simply means that running this nice using this parameter, by simply running this command, this will allow us to escalate our privilege from www.data to if. The -p here means that when we are running this file that belongs to if, we know we will be temporarily getting if EUID and SUID. We want to stay on as if so that we can pretend that we are if instead of going back into www.data. So we can simply copy and paste this command into our terminal to execute this exploit. Press enter, and now let's do a who am I, and you can see we are already escalated as if. And that is how GTFObins works. Now, another example. Let's say I want to gain root access, and fortunately for us, there is a file that belongs to root which happens to be vulnerable to the GTFObin exploit. So we'll do this the same way. We'll run this flop and try to stay on as root. Going back to the GTFObin website, I look for the flop so that I get the parameters to execute the exploit. And this is the line that we'll be using. Copy this into your terminal and do a who am I. Now you can see I have already gained access to the root user. So what we have done here is that we started from the lower level user www.data, and we run nice, which happen to have the S permission here to gain access as if and stays on, and then we go even further by executing this flop to gain access as the root user. Now of course, this hack works for many other binaries that has the S bit set to 1, and it really depends on whether the system is currently having this file that you can find and use on. So if you find this to be difficult, you can always use the limpy script that will automatically scan the system and find out which file or binaries is currently having S bit set to 1 that we can use to our advantage.